Lesson 1-7, compute with scientific notation. Looking at all of this multiply, divide of the scientific notation, and the result express the result also in scientific notation. Now to do this number, the 3.4 you times by with the 2.3, and the 10 to the power you work with the 10 to the power. So let's work on the number in the front first. 3.9 you times by 2.3, that will give you 8.97, and then you times in the middle, and 10 to the power of 2 times by 10 to the power of 6. If you refer to our previous lesson about exponential, then you will know that when they are multiplied with the same base 10, the exponent is plus together. So 2 plus 6 become 8. Let's go, move to number 2. The same idea. 4.18 times by 9. 4.18 you times with 9. That will give you the answer 37.62. 37.62 multiplied by 10 raised to, now the negative 4 with the negative 4, which means that you have the exponent is the same base of 10, so the exponent plus together, negative 4 plus negative 4, that will give you a negative 8. But it's not complete answer yet because you have 2 digits in front of the decimal point, so you have to move one step to the left, which means that 3.762, that will be your final answer, multiplied by 10 raised to. Now when you move one decimal place to the left hand side, which means you times by 10 to the power of 1, or in other words you plus 1 to the exponent. When you move one time to the left, so you plus 1 to the exponent, so negative 8 plus 1, that will give you a negative 7. This is the final answer. And for number 3, 9.75 times with 8.4, that will give you this number 9.75 multiplied by 8.4, that will give you the 81.9. And then for the square root, for the power, 10 to the power of 3 times 10 to the power of negative 6. So 3 plus negative 6, that will give you a negative 3. So you have 81.9 times negative 3. So when you move one decimal place to this side, become this number. I'll try to break this one down for you, times negative 1, or times 10 raised to 1, or you move one decimal place, which means that move one decimal place to the left, which means that you plus 1 to the exponent. So negative 3 plus 1 will give you a negative 2, just like number 2. Now for number 4, this is division, but the same idea. You work the number in the front, you work together, the 10 to the power, you work together. So 9.45 you divide this time by 1.5, that will give you 6.3. 6.3 multiplied by 10 raised to. Now this is division, then the exponent you minus. So again, let me repeat, let me show you the let me review a bit on the number 1. This is multiply, you plus the exponent. This is divide, you minus exponent. So 10 minus 6, 4 as an exponent. Number 5, 1.14 divide 1.14, you divide 4.8. That will give you a 0.2375 times with 10 raised to negative 6, this one 6 minus 6, so which means 6 plus 6, 12. Let me repeat. This is minus, but 6 minus, and then you minus with the minus 6. So 6 become plus 6. So 6 plus 6, 12. This is not complete yet. You have to because the digit in front of decimal point is 0. You have to move one decimal place. One decimal. You have to move the decimal place to behind 2. So you move one time. So you have 2.375 times 10 raised to now. Our previous example, when you move to the left, you plus 1 to the exponent. This time you move to the right. So you move to the right one time, you minus 1 to the exponent. So which means that 12 minus 1, 11. This number 9 divided by 2.4. 9 divides 2.4. That will give you a 3.75. And then negative 11 minus 8 become minus 19. You don't need to move any further. That's all complete. Let's move on further to number 7 all the way through number 12, which belongs to this instruction. Evaluate each expression. Express the result in scientific notation. So this is a 10 raised to 11. This is 10 raised to 9. So let's make this one to 10 raised to 9 as well. So this is you could have 9. Let me break this one down a little bit for you. For number 7, you could have this as 9.5 times with 10 and times with 10 raised to 9 like this. Okay. Now how do you? So you have this one 2. So 2 plus 9, 11. Okay. So now you have, the reason we try to break down like this because we want the first exponent here, the 10 exponent must be equal exponent so that you can easily for us to calculate this part to evaluate it. So you have 9.5 multiplied by 100. That will give you a 950 times 10 raised to 9. Okay. You just move 2 times. 1, 2. We give you a 950 to and times 10 raised to the power 9. After that, you plus with 6.3 because they are so the power of 9 stay the same. I mean, 10 raised to the power of 9. Now let's work on this number. You have 950. You plus with 6.3. That will give you a 3.659. So you have 956.3, but you need to move decimal to this side. So you write your answer at this part as in 9.563. Now, last time, previous example, when you move to the left, you plus. So you move how many times is it? 1, 2. You move 2 times, which means you plus by 2. So 9 plus 2, that will give you 11. See? Number 8. Now for number 8, same idea. You have this is raised to 9. This is raised to 7. You have to make this into 7 as well. So you have 1.03 times by 10 times again by 10. Let me put this one as 7. So to make 9, 2. So you have 1.03 times with 100 because to the power of 2 is which will make 100. This one will give you a 103 to the power of 7. Then you do the minus 4.7 to the power of 7. Let's work on this together. This is 10 to the power of 7. Stay the same. This part, 103 minus 4.7, that will give you 98.3. 98.3. Now, you need to move on to the one decimal. You have to move decimal to the left one time, so that you will have a 9.83 times with 10 raised to. Now, when you move to the left, you plus. Move one time plus 1. So 7 plus 1, 8. For this part, well, you need to work on this section then. Oh, well, let me try to find the best way. You can either make this into this number that give you a lot of thing to work on, or you can make this into a scientific notation first. Right, so let's try to make this into scientific notation. So if you move decimal, you have 5.9 times 2, 10 raised to 1, 2, 3, 4, 5. 5 times. Okay. And you have another, then you have to make this into power of 5 as well. So you will have 1.357 times 10 and times 10 again, raised to 5 right here. This is 9. You have 5 already. To make 9, 4 more. So you will have 1.357 you times with 10 to the power 4. That will give you a 13,570. And then this is the plus, so this number and this number you plus together. So you 13,570 you plus with 5.9, that will give you 13,575.9 times 10 raised to the power of 5. This is not complete yet. You have to move the decimal. So you move to the left hand side. 1, 2, 3, 4. 4 times. So 4 times. So 4 or 5 plus 4. That will give you a 9. So complete answer 1.3 thousand. Oh no, this is 35759 to the power of 9. The rest, this part you do the same like this number. Let's look at number 11. The number 11, I think somehow it belongs to this section. Well, yep. So let me just do this part again for you, just for the sake of reviewing. 3.24 you divide 8.1. That will give you 0.4. And then minus 4 minus 7, or minus 4 plus 7, that will give you a 3. This is not correct answer in scientific notation form, so you move decimal behind 4. So you have 4.0 times 10 raised to. Now when you move to the right, you minus. So you move one time, you minus 1. 3 minus 1, 2. This section already give you the answer. You might do by yourself how to get to the answer. I already showed the way how to do it, so you can, at least you can work number 12, 10 and 12 you work by yourself. Number 13 all the way through to number 16, which is the end of our lesson 1.7. Oh yeah, 1.7. Now number 13. Neurons are cells in the nervous system. This is wrong spelling. That process and transmit information. An average neuron is about 5 times 10 raised to negative meters in diameter. A standard tennis table ball is 0.0 meter in diameter. About how many times? Ask rate. Okay, so the diameter of a neuron, this very small, very small, as to see the negative, and the tennis ball is large comparing to this one. But the question is like this: how many times larger? So you simply use this, the diameter of the ball divided by diameter of the neuron, then you will have your answer. So 0.04 you divide by this number, which is divided by 5 times 10 raised to the negative 6. That will give you an 8,000 times larger. Number 14. A Central Park in New York City, rectangular shape. Okay, this is a rectangular shape. Let me try to draw this one out for you as a rectangular shape. You have the length and the width. Okay, the length longer, of course. You have 1.37 times 10 raised to 4, and the width is 2.64 times 10 raised to 2. Now, if 1 acre is equal to 4.356 times 10 raised to 4 square feet, how many acres does the Central Park cover? Let's talk about square feet. So you need to find the area of the rectangular shape of a Central Park. So you get area first. So to get area, 2.64 times 10 raised to 2, what is the width? So area of rectangle is the length times the width. So the 2.64 times 10 raised to 2 multiplied by the length, which is 1.337 times 10 raised to 4. Now that's will give you approximately is you multiply together, it gives you 300. So this is a 361.6. So this is a 3,616,800. This is as in square feet. Now once you have that, once you have the area of this rectangular shape, and you divide this area by the scale factor, which is 1 acre equivalent to 4.356 times 10 to the power of 4 square feet. So 3,616,800 you divide by 4.356 times 10 raised to 4. That will give you, this is set round to the nearest hundred, that will give you a 83.03 acre. Okay, approximately like that. Number 15. For number 15, this is swimming pool. This is the volume of swimming pool, and it is filled at this rate, 1.5 times 10 raised to the power of 3 cubic inches per minute. So you try to fill in the pool which can hold this much of water. So how many hours does it take to fill the swimming pool? First of all, you need to find how many minutes does it need to fill first. So to find how long it takes to fill the tank, the swimming pool, sorry, not the tank, the swimming pool in minutes. So you use 1.2 22 times 10 to the power of 6. This number is the volume of the pool divided by the scale factor, or divide by the rate that it takes per minute to fill the pool. So you have 1.22 times 10 raised to 6. You divide by 1.5 times 10 raised to 3. That's give you approximately about 813 1/3 minutes to fill the swimming pool. This is in minutes, but the question asking us for hour. So once you get this number, you divide by 60, because 1 hour is 60 minutes. So you divide by 60. That will give you the final answer as in hour, which is 13. Let me that will give you a 13.5/9 hour. You have 13.5/9. This is the exact hour, exact number of hour. Let me do this part again. It says, oh sorry, I write in the wrong part. This is not the answer to this. It should be up here. 13.5/9 hours. Let me do this again to make sure. 1.22 10 to the power of 6 to divide by 1.5. Divide by 1.5 10 to the power of 3. Okay, after that you divide by 60. And that will give you the 13.5/9. Alright, let's move on to the next, which is the last number in this section. 2010, the national debt of the United States was about 14 trillion. Okay, trillion, which means 14 trillion, which means 14 to the power of, the trillion, which means you have 10 to the power of 12. You have 14 to the 10 times 10 to the power of 12. In 2003, it was about 7 times 10 to the times 10 to the power of 12. So one is 14, one is 10. Obviously, you can see the 12 doesn't work with this part. You don't need to worry about it. To the power of 12 to the power of 12, because they are the same. All you need to do is you work with these 14 and 7. So obviously, how many times larger? 2 times larger. Or you simply use 14 times 10 to the power of 12 divide by 7 times 10 to the power of 12. This simplify. 14 divided by 7, 2. So 2 times larger. Lesson 1-8, roots. Evaluate each root. Okay, now the final root of a number. For example, in number 16, what number multiplied by itself can make 16? So you have 2 times 2 is 4. Think this part. Let me have a think a bit on this. So you have 2. 2 times 2 is 4. Now, if you have 3, 3 times 3 is 9. If you have 4, 4 times 4 is 16. Okay, so now you have this part, 16. So which means that the root of 16 will give you 4. That's how you find the root. Now, number 2, this negative, write down the negative first. This will up to 400. Now think this way with me. If you have 10 times 10 or 10 square is equal to 100. if you have 20 times 20 or 20 square, that will give you 400. This 400 something, so which means that this number somehow 20 and above, 20 something, 21, 22, 23. Now if it is 21 or 21 times 21, the one digit is 1, because 1 times 1, you write in vertical form, 1 times 1 is 1, but the one digit here is 4. No, so I guess not. So how about 22? So 22, you have 2 times 2 is 4. Okay, that reasonable. 4. You must think of other number. 3 times 3 is 9. 4 times 4 16. 6. 5 25. 5. And then 6 times 6 36. Number 6 here. So I guess this is the appropriate number for us to determine what is the answer to this section, because 2 times 2 is 4. It is 4 in the 20s section, so that will be a 22. Number 3, write down the negative first. 36, so it below 10. So let's work on this all the way through. 4 times 4 16. 5 times 5 is 25. 6 times 6 is 36. Okay, now we have already 6 right here. This part you need to work both the 9 and the 49, but this is plus and minus, so write plus and minus first and a fraction bar. Work on the first number, or we call the numerator, square root of 9. 9 is 3 times 3, so the answer here is 3 up here. 7, you can put right here, 7 times 49. 7 times 7 is 49, so that will give you 7. Minus first, 256. 256. Oh, this is 2.56, but to avoid confusion, just think of 256. So think this is 200, it below 20. If it is 400, it's above 20. So it is 200, so below 20. And you need to think what number will give you the 6 at the back. I think 16. Try 16 with 16, because 6 times 6 is 36. 3. 6 times 1, 9. 6 times 1, 6. 6 plus 3, 9. 6, 1. So 6, and then 5, and then 2. Okay, so 16. But since it is decimal place, so 1.16. See, as simply as that. This one means the same. 25 a while ago. 25 is 5 times 5, so that will give you a 5. But since it is decimal, so 0.5. To check with me, 0.5 times 0.5, that will give you a 0.25. Let's move on to the third root in this case. Okay, third root. Now this time think of a number that multiplies 3 times to make 216. Think of a number that multiplies 3 times. If 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125, and you continue on at this one. How about 6 to the third? 6 to the third is 216. Okay, 6 to the third is 216. So it's minus 6, because of 6 to the third is 216. And you can continue further. How about 7 to the third? 7 to the third, 343, which is correct. So this is 343. So a minus 7 is also minus here. You can continue further to 8 to the third. 8 to the third, that will give you 512, which is correct. So 8 is the answer here, negative 8. 1,728. This some thousand. So 1,000 is 10. 10 to the third is 1,000. 10 to the third is 1,000. So this is 1,000 something. 28 at the back. 1,000. How about 700? Is about above 20, which will give you a 10 and I think about 14 or about 12 in this case. I think 28. Let me try 12 to the third first. 12 to the third. Yep, I think 12 to the third is correct. So this is 12 to the third. So that will give you 12 as in the answer. Negative. This is 125, which means 5 to the third. So you have 5 first. But this is decimal place, so 0.5. This part, fraction bar first, work on the number up here. 27 to the third, which is 3. 125 to the third, which is 5. Okay. Now in this section, solving equation. So the equation, you have v squared equal to 81. To find v, we call solve equation using the square root. So square root of v or square root of this one, both sides. So you have v is equal to square root of 81. You have 9 because 9 squared is 81. Same way with this, square root on both. You have this as square root of 36 is 6, square root of 100 is 10. Simplify it, you will have 3 over 5. You also apply the square root 169. Think of 169. So square root of 69, I think this is 13. Let me check for 13 times 13 or 13 square. 13 times 13 square. Okay, 169. This is 13. But since it is decimal, so this 0 point something decimal. So I believe this has 0.13. Let me check with you. Check for you. 0.13 square is all check. 0.0169. This is to the third root. So the third root of 1,000 is 10. This is also to the third root. The third root of 1 is 1. The third root of 8 is 2 because 2 to the third is 8. This section, this part give you square, you apply square root. This is give you the square root, you apply in the square. So put square. Square and square root you eliminate. Only x. Now 5 square is 25. Same idea with this, using square and square. Square with square root, eliminate. You have y. And then 20 square. 20 times 20 will give you 400. The last one. Z square. And then 10 to the 0.5 to the power of 2 as well. So this is z remain. But the next section is 10.5 square. That will give you a 110.25. Okay. Now 21, the last number in section 1-8. The concert crew needs to set up some chair on the floor level. Okay, the chair are to be placed in a square pattern consisting of 4 square sections. If one of the square section holds 900 chairs, how many chairs will be along each length of the largest square. Okay, let me try to draw you a figure to give you the better picture of the problems. You have 4 square section and it's a square pattern. So you have like this. The 4 sections are equal. They are equal square, and the 4 combined make a larger square. So if one of square section hold 100 chair, okay, how many chairs will be along each length of the largest square? Okay, so they ask for how long is it from this side all the way to this side, or if you find one side you can find the other side because it's all square. But first you need to find what is the length of this. When you find this length, you also can find this length because they are the same. So this square section here make 900. So to get the side length of the square, you're using square root of 900. So square root of 900, that will give you 30. So in other words, you have 30 on this side and 30 on this side, and that make up a 900 square section in this particular part. So if it is 30, it's also 30. They are so 30, 30, 30, 30, and 30. Then to answer the question, how many chairs will be there along each side length of the largest square? As you can see, 30 plus 30, 60. 60, 60, 60. So together, to answer the question, 60 chairs. 60 chairs.